going to be showing you Universe Sandbox Simulator. So you're going to hear lots of mouse clicks and some keyboard clicks as we explore our solar system in a way you may never have seen before. Universe Sandbox Simulator has a lot of fun tools that allow us to change things like the flow of time to help us get a good understanding of how the planets move and how our universe works. Let's start with our most familiar planet. This is actually a synced live simulation of our solar system right now. We can see our planet as it would appear if we were observers from space today at this minute. We can see it is just becoming morning for some of our friends in Europe and Africa. And where I live in the United States, it has just become night. And for our friends in South America, they are about halfway through their night. We can see things flying around like the Hubble Space Telescope. It looks so small compared to our planet. It looks like it's frozen, but it's actually traveling so fast. Earth is made up of a lot of unique elements and chemicals that aren't present in a lot of our solar system. It's what makes Earth so conducive for life here. Our closest neighbor in our solar system would be our moon. Earth's moon is the third largest moon in our solar system. It is made from the Earth, and it is suspected it was created when a large body struck Earth in its early days, ejecting material, giving Earth a small ring until that material collected to form our moon. Our moon is actually more than 260,000 miles away from the Earth, over 400,000 kilometers. Our moon is so far away, you can fit every single planet in between Earth and the moon, pole to pole, including Earth, and including the most massive planet in our solar system, Jupiter. Jupiter, the largest planet in our solar system, is made primarily of hydrogen and helium, just like our sun. Jupiter is actually a pale star. If Jupiter had gotten 80 times more massive during the formation of our solar system, it would have been heavy enough to start fusing hydrogen into helium in its core from its gravity, which would have made Jupiter into a red dwarf. If that were to happen, not much would change for Earth, as Jupiter is actually 4 times as far away from us as we are from the Sun. Jupiter's increased size and brightness wouldn't affect us much. It would only be about as bright as our full moon. Isn't that fascinating? Jupiter is home to the most moons in our solar system and the largest moon in our solar system, Ganymede. Ganymede is so large. It is 41% of Earth's radius, but it is much less massive than Earth. Only 2.4% as massive as Earth. Ganymede is made mostly of light rock and ice, so it wouldn't have as strong gravity as Earth. But its size, even larger than Mercury, makes it so interesting. The second largest moon in our galaxy, our solar system, is Titan, one of Saturn's many moons. Titan, similar to Ganymede, is about 40% the radius of Earth, but still only 2.2% as massive as Earth. Titan is made up mostly of light rock and liquid methane. Saturn, whose rings are not pictured in this simulation right now. Saturn's rings are made up of mostly ice and very small boulders and rocks that circle around the planet up to 400,000 kilometers off of its surface. That's really far. Maybe we'll come back and take a look at Saturn's rings. Saturn is also made up of helium and hydrogen, similar to Jupiter, but it's not nearly as massive. It's barely 30% of Jupiter's size. The next planet in our solar system is Uranus. the farthest planet from our sun, is also made of hydrogen and helium and methane like Uranus to give it its color. Let's take a look at the dwarf planet Pluto. Pluto is so small, even smaller than Earth's moon, and not as massive either. So we don't even consider it a planet anymore. We call it a dwarf planet. Pluto is actually a binary system, as its moon, Charon, is almost as large as it. In fact, Charon is so massive compared to Pluto that Pluto's center of gravity is about 71 miles off of its surface, in between Pluto and Charon. Pluto and Charon are tidally locked to each other, always facing the same sides towards each other as they orbit around each other and around the sun. It's so cool to see how Pluto and Charon interact with each other as they dance around our solar system. Let's see if we can view their trails. There, you can see the way Pluto and Charon's trails swirl around and dance millions of miles away. Thank you for exploring our solar system with me today. I had a great time looking at the outer planets and learning more about their composition.